thought of covering different related package managers, which all focus on so-called Conda packages. And that has become a fairly popular way of distributing and installing scientific software. And the overall idea is to be, or the aim is to be fairly fast and user-friendly. So it's definitely interesting, especially for like rapid testing, rapid prototyping. But there are definitely various drawbacks as well, and so we will cover those as well. Wait, that's the first slide. Yeah, the first I will introduce some of the main concepts and ideas, and introduce different, what you could call different implementations, and so mini Conda, mini Forge, Pixi, etc. Then we'll go through the TB-Lite example with one particular implementation, mini Forge, and we'll go more quickly through the other implementations, and then list the various things to watch out for and show what you can try out as homework. So some of the main ideas behind Conda packages is that, okay, initially there was mostly some focus on Python and R software, but that has definitely become more general over the years. So pretty much anything can be offered as a Conda package. For example, TB-Lite is a Fortran code, and so that's also available as a Conda package. This kind of automatically. Okay. And yeah, also it's normal to have different environments that you can isolate from each other, which are definitely the way to go, because not all your software stack I mean, you can have conflicting dependencies when you are not using independent environments. And so those Conda packages are always precompiled packages, because that's definitely necessary to be able to install them very quickly. But yeah, as you can imagine, precompiling also has some drawbacks with respect to performance, for example. So we'll go in more detail about that later on. It's also definitely the idea to always be self-contained, and so Conda pulls in a whole lot of dependencies, and it's only like really the ones that are really part of your core operating system, for example, glibc on a Linux system, that are taken from the host, so to speak. And yeah, in contrast to, let's say, a regular package manager, yeah, Conda is definitely assumes that you don't have root privileges, and so everything should work with regular rights. Another thing to definitely keep in mind is that only specific, let's say, platforms are supported, or that Conda packages are only made available for certain platforms, platforms being a combination of a specific CPU architecture and operating system. So here you see what those are. For HPC, it's of course mostly the Linux x86-64, and so this Linux x64, that is the one that applies to you. You might also maybe encounter clusters with ARM CPUs, and then you would be targeting that platform instead. If you don't have Linux on your local device, then yeah, you would rather look at the OS X or Windows platforms. So one more thing to keep in mind is that not all packages might be available for all platforms. So if you maybe have some package that you know from experience that is available for Linux, for example, you may not find it for Windows. That kind of depends on the provider of those packages, for which platforms it is built. Maybe not something you will run into that will be problematic, but it's something to keep in mind. Another concept is that, yeah, a bit like a regular package manager, there are various repositories from which you can pull those packages, and you have defaults, and those repositories are called channels in Conda language. So you have so-called default channels like main and R. But already one thing to keep in mind here is that there are certain terms of service that prevent you. Well, that's if you're a commercial user, you will need to have a paid license to use those. It's only if you're an academic user that those are free to use. So in general, we would recommend to rather look to the community channels like CondaForge and BioConda, where there are no license terms to take into account. And then there are some, say, for example, vendors also have specific channels, like for example, Intel maintains an Intel channels where ideally the packages contain optimization specific for Intel CPUs. So if you're targeting Intel CPUs, that can be worth looking at. Here you see the different, what they're called different implementations, so different packages managers which all focus on Conda packages. So you have Anaconda, Miniconda, Miniforge, Mamba, and Pixi. The examples we will show will involve Miniforge, which is the one we would kind of softly recommend, but I would not say it's a hard recommendation. If there's anything I would recommend, it would be to not use Anaconda or Miniconda unless you would have specific reasons to do so. The difference between Miniforge and Mamba, I would say, is rather small. And Pixi is also in many respects fairly similar, but has some features which you might find interesting. So, but that will come later. So now I will try to showcase the TB Lite example with Miniforge. So yeah, it will be in the slides, but I will just switch to a terminal to illustrate it. So if you want to use Miniforge, but it's fairly convenient, I would say on our, okay, a bit larger, like this. You can just load a Miniforge module. The slides show how you can make sure that your Conda configuration is well set up with respect to the where you are installing your environments and where you are keeping your package caches. So here you see how my Conda RC looks like for the demo. I just configured those two directories to be in the /tmp folder just to speed up the example a little bit. Normally you would specify VSC data here and maybe VSC scratch for your package caches. And if you want to check your settings, you can do Conda info, where I think the main things you can check, for example, is that Conda correctly picked up your directories there. You already see normally, here you see the platform, Linux 64, which is also what you would expect on our VSC clusters. And this is then how you would create an environment, here just called my first env. Conda will ask, okay, whether this is where you want to put it, okay. And then you can, Conda will recommend to activate it with Conda activate my first env, but for reasons that are somewhat convoluted, I would not recommend to do it this way, but rather always use source activate and then the name of your environment. You can use Conda env list to check what are your environments and which is the active one. So we are in my first env, which is good. There is a base environment associated with the Miniforge module, but you will not have read or write permissions to that directory. So you're definitely not expected to use the base environment here. And then you can search for available packages for your platform with Conda search. Here, for example, you see the TB Lite Python packages. As you remember, CondaForge was a channel that I enabled, so you only see results for CondaForge. You see different, for each TB Lite version, you see different packages I mean, the main thing to maybe look at here is that, yeah, there are different packages, for example, for different Python versions. So you could install it with Python 3.9, 3.10, 11, up to 3.13. Here, we'll just go, I think, with the latest Python. We'll see. Anyway, this is how you would install a specific DB-Lite version. And what then happens is that, yeah, the solver determines what packages it all needs to pull in, which are quite a number, of course. So it includes, yeah, here Python 3.13, DB-Lite itself, of course, the Python interface, NumPy, etc., etc. We'll proceed with installing them. So that went relatively quickly. The DB-Lite executable will then be in this bin directory. Yeah, we'll just skip that part. Your Python interpreter will be also in that directory. And then, yeah, this is just a quick sanity check to see that it's installed properly. So in this default case, it uses or Conda chose OpenBLOS to provide the BLOS and LAPACK dependencies. You can tristash to something else, like for example MKL or Bliss. In this way, and so especially I would say on an Intel CPU, would make sense to try MKL. And so this will uninstall OpenBLOS and install MKL instead. And let's see, yeah, you can check that by see what the liblappack links to. Yeah, that was it pretty much. You can, if you want, you can clean up your caches in this way. And you see that already in this small example, we already pulled in, let's say, 240 megabyte in package caches. So we can remove that after a while. And then this, the following commands are just to illustrate how you could use Conda tree to analyze dependencies of a Conda environment. It does that by creating a second Conda environment. Also showing how you can use an environment file to specify your dependencies. And here we install Conda tree 1.1.1. And yeah, this, if you then do Conda tree -n my first and dep tree, you get a whole list showing what Conda package depends on what. It can definitely be worth having a look. And then the final part here is where we again activate the environment and run this one demo script. And so here you see the results, so the DB-Lite calculation. Okay. And that was it for Miniforge. Yep. So just going quickly through the other implementations, Miniconda is similar, but if you and there are some drawbacks in the sense that, in contrast to Miniforge, the default channel like main and R are enabled by default. So it might not be a problem if you're an academic user, but once you are not anymore, then it can be a problem. In Miniconda is also easier to install packages by mistake in your base environment. So you have to watch out more when you use that. And this has more related to the fact that you would be using a local installer, is that, yeah, you also have this base Miniconda installation, which is then also taking up additional disk space and inodes. So yeah, this is how we would download this local installer. And then to initialize, it's best to remove this Conda RC file so that it's Conda relies on the one in your VSC home. And then just updating your path should be sufficient to start using it. And then the other Conda commands are quite similar to the Miniforge one. And this is just an example how you can create an environment and specify what packages should be installed. You can do that in one line instead of 2 lines. But for the rest, it's very similar. Micro Mamba is arguably more similar to Miniforge. One key difference perhaps being is that Micro Mamba is really just a single executable where everything is contained. And in contrast to Miniforge, where you can use some commands to automatically configure your Conda RC file, you need to do that manually in the case of Micro Mamba, but that's just a small difference. And this is how you would download this executable. This is how you would preferably initialize your shell, let's say. And similar, I mean, basically everything you would do with Conda, you can do with Micro Mamba instead. So I said if you do Conda info with Miniforge, you would do Micro Mamba info with Micro Mamba. So yeah, all the rest is similar to what we had before. Pixi, here we see the main difference is that Pixi are a bit more designed in terms of creating different so-called projects and then specifying different environments within each project, which can be worth reading up if you find that interesting. And that it also uses so-called log files, which can be make it a bit more clear to you what has really been installed in your Conda environments. So it could be that reproducibility is a bit easier to achieve with Pixi than with the other ones. So again, for the TB Lite example, this is how you would download the Pixi installation, how you would and how you would activate your environment. This then is a bit different from the others. You don't do Conda create something, you would rather do Pixi init, and then the directory of your environment. You then need to switch that environment, and then you can start installing packages like TB Lite Python. So again, those are actual Conda packages that you would be installing. Your Pixi list again shows what is installed, and then that directory will have a TOML file which shows what you actually installed. That's again TB Lite Python. So that is that. So we already covered some drawbacks in the process, but we'll list them again here. So unless you configure your Conda IRC file, so you have to specify your package directories and environment directories, because otherwise either your environments or your package caches end up in your home, which of course would fill it up very quickly. Conda environments, I mean, you can combine your Conda environments with certain modules which are, basically standalone binaries, but not with like any other modules. Like don't think of combining Conda environments with, for example, FOSS24A or whatever kind of software stacks. So a bit more about the microarchitectural optimizations. So whether or not your Conda packages have optimal code for the CPU on which you're running, it really depends on the package. It is not something that is, I mean, the base case is actually that Conda packages have just been compiled for generic CPUs. And so there are no, for example, AVX or AVX2 optimizations instructions in the code associated with your Conda packages, unless the person's packaging or providing this Conda package explicitly provides different builds for different CPU microarchitectures. And so some packagers do that, but definitely not everyone. And in the case of TB Lite, it's just generic CPU microarchitecture instructions. So for the Fortran part of TB Lite, you will definitely see reduced performance compared to, for example, a TB Lite module installed via EasyBuild, for example, compiled from source. Also, with some Conda packages require MPI, and we have definitely seen cases where that has given either performance problems or that has been like multi-node runs are hanging because the MPI library or the MPI settings were not configured correctly. And so that's something to be aware of. In regards to storage, as you can imagine, since Conda is pooling pretty much every dependency of your packages, it means that the Conda environments tend to be very large, and both in terms of number of files and in terms of space. So it's not uncommon for Conda environments to be several gigabytes, tens of thousands, maybe hundreds of thousands of files. So that's on some file systems that can be a little bit too much. And for example, at least the number of inodes, you can reduce that by containerizing. And so you can create a container environment in a Conda environment inside a container, which would just show up as a single inode. Base environments, you need to watch out in case of certain implementations that you already mentioned. And default channel terms of service you also already mentioned. And then this last thing is just to show that you can easily reproduce Conda environments on the same platform via these Conda export commands and Pixi export commands. But that will also, that will only work for when you need to copy a certain environment on the same platform. But if you have different platforms, you need to remove the so-called build strings in this way. And then you can recreate the environment on this new platform. So that was that. Here you just see how you can try things out with another package. So not TB Lite, but Alpa, which can be nice to check how CPU microarchitecture support, for example, looks like. So yeah, that's the homework. And that concludes the Conda Mamba Pixi part. So if there are any questions, we'll be glad to take them.
Somehow we're perfectly on time. Are there any questions on Conda, Mamba, Pixi?
Oh. I remember earlier comment from HPC uses that Conda is not really advised. Is it the pre-compiling issue that gives a suboptimal usage, or are there potential conflicts that we should be aware of?
So the main concerns are the lack of microarchitecture optimizations and the storage. I mean the large storage demands.
Yeah.
And especially I think at Brussels, Ghent, and Antwerp, we kind of tend to more strongly discourage these environments.
For Ghent, a big reason is that it's very easy with Conda to shoot yourself in the foot in terms of filling up your home directory and Conda making changes to your bash RC startup script, where it just activates whatever environment you were playing with last. and then you log out, you log back in again, you load modules from the central software stack, and stuff fails in very weird ways. We've already recognized, we started recognizing tickets that say if the issue is very weird, the first thing we do is look into the Bossche startup script, and 99% of time there's a Conda activate in there that's causing the trouble. So that's together with the lack of optimization and the big number of files that you need. I mean, it's a combination of things that we don't generally recommend it. But if you're careful enough and you understand better what you're doing, it's okay, right? As long as it works for you and you're not causing trouble in other use cases, fine, use it. Yeah. But it's important to be aware of all these, rough edges, let's say. Yeah. And I think the main thing is Conda and all these other tools around it were never intended to be used on HPC clusters. They work well on laptops, but as soon as you go to an HPC cluster where they have a very small home directory and limitations in terms of number of files and stuff, then it becomes hairy very quickly. Yeah. I think that's something.